Okay, part A is straightforward finding the components. So AB is equal to B minus A, which is equal to 339 minus 1 negative 1, 4, which gives me 2, 4, 5. One mark available for that, and you have to get the correct component form. Part B, we're asked to show that these 3 points are collinear. Now there are two conditions for collinearity. The lines must be parallel, they must have the same gradient, and they must share a common point. So we need to find the component form of BC to be able to do this, which is C minus B, which is 9, 15, 24, minus 339, which gives us 6, 12, 15. And what we're looking for here is we're looking for this vector to be a multiple of the one that we already found, or the other way around. I'm going to take out a factor of 3 here. And we'll be left with 2, 4, 5, which is the same as we got for the original AB. So 2, 4, 5, BC is 3 times 2, 4, 5. We've got to, that's not enough to just do that work, and we've got to show what that means. So BC is 3 times AB, as BC is a multiple of AB, and they share common point B, A, B and C are collinear. Okay, and there's 3 marks available for that part, which will be 1 for calculating this first part, 2 for the multiple, and 3 for stating what's required for collinearity. Okay, question 2, we're asked to find the coordinates of a point which divides a line in the ratio 3 to 1. We must draw a picture here. So I've got a line AB, I've got a point C, which divides that in the ratio 3 to 1. Now I can set up my proportion. So AC over CB is 3 over 1. I do a cross multiplication. AC is 3CB. I'm going to break that out. We can find AC by C minus A, and 3CB is 3B minus 3C. C is the point I'm trying to find, so I'm going to move all my C's onto the left hand side of the equals. So I've got C here, and when I move that 3C over, I end up with 4C. I've still got my 3B here, and I'm going to take my A over. Now I can start to sub in. So I've got 3 times B, which is 5, 4, 10, plus A, which is 1, 0, 2. 3 times 5 is 15, plus 1 is 16. 3 times 4 is 12, plus 0. 3 times 10 is 30, plus 2 is 32. Now I must remember that's 4C. So C is going to be a quarter of that. So it's 4, 3, 8. And that, as a coordinate, is 4, 3, 8. And 3 marks there. one for setting up correctly, one for getting to this point here, and the third for getting your actual coordinates. Now, question 3. Choosing the scalar product. We're given two vectors in component form and we're asked to find the dot product. When they're in component form, it's straightforward. Remember, this is on your formula sheet. So PQ.PR is equal to negative 2 times 4 plus 3 times minus 4 plus 5 times 4, which is negative 8 minus 12 plus 20, which equals 0. Part B. This particular example that we have here, we know that if we have a scalar factor of 0, the lines are perpendicular. So straight away we actually know the answer to this question is 90. But I'm going to go through the process because you won't always get one that's that straightforward. We need to use the other form of the dot product, which is also on your formula sheet. So we'll start by writing that out in terms of our letters. So PQ.PR is going to be the magnitude of PQ times the magnitude of PR times the cosine of the angle in between. We want to find the angle in between. So we're going to rejiggle things and we get cos theta equals the dot product divided by the two magnitudes multiplied. I can sub in 0 on the top. Magnitude of PQ is the square root of each of my components squared, so it's 4 plus 9 plus 25, and I'm multiplying that by the magnitude of PR using my 3 components there. I get 16 plus 16 plus 16. So I'm going to end up with 0 over root 38 times root 48, which in this case of course equals 0. To find theta, I will do an inverse cos. Now of course I already know the inverse cos of 0 is 90 degrees. 5 marks for this question. 1 here, 1 here, here, 1 here, and 1 here. So we need to know how to use both forms of the scalar product. We need to know how to rearrange the second one to find the angle. We need to substitute incorrectly, and we need to remember to do an inverse cos. And we need 9 out of 12 to pass outcome 1.